Morning students, how are you? I'm Francis sir and today I'm back with standard 7 physics. Okay, so without delaying let's start our class. Okay, so yesterday we did discuss about motion and time. We did discuss about average speed. Yes, we did one numerical also regarding it. I hope you are practicing that type of problems. So today we will be seeing graphical representation of motion. Means how do we represent a particular motion that is happening in a graphical way. To understand the graphical representation, you need to first know or understand what is a graph. So this is one diagram. You will see that this type of structure, this is called a graph. A graph consists of two lines, this is called axis. One is called x axis and another one is y axis, and both are perpendicular to each other. Both of them are perpendicular to each other, and the point at which they intersect is called origin. The point of intersection is called O, and it is called origin. Okay. So the thing is that why do we require a graph? What is the importance of graph? So graph is required. Let me tell you one instance. If I say that where are you, then you will be saying that I am at home. So the position that you talk about yourself, that at what place or what position you are, you need to talk. You need to say a landmark means you put on your position with the help of a reference of something. For example, you are at home, that means home is your reference. If I go your home, I will find you. Or if somebody is at Kargil Chowk, if I ask that person, where are you, that person will be saying that I am at Kargil Chowk. So Kargil Chowk is a reference point which gives the exact location of that person. So we always need a reference point for our location, or sometimes we need a reference reference frame in order to show a particular type of information. So that's why graph is very important. So the more the reference point, the better is the information. So here generally we don't take one reference frame, we take two reference frames. One reference frame is your x-axis and another reference frame is your y-axis. When these both are combined together in perpendicular manner, they are said to be a graph. Okay. So I put one example here. So let us suppose that we have a point P. So how do we locate this point in this graph? So what do? We draw a perpendicular line. You might be seeing that there is a dotted line, but I am making it dark. Okay. So this is a perpendicular line of x-axis on x-axis. So this gives you a reading at 4. So I can say that this point is 4 units away from the y-axis. The reading in the x-axis tells us how far is the point from the y-axis. So the reading on the y-axis tells us how far is a point from the y-axis. You can see, for example, if the point is here, it is 1 unit away. If the point is here, it is 2 units away. If the point is here, it is 3 units away. If the point is here, it is 4 units away. So this reading on the x-axis tells us how much far is this point from the y-axis. Okay. Now, if you want to get a y reading, we will draw a perpendicular on the y-axis. We will draw a perpendicular on the y-axis, and this reading on the y-axis, this is your -3. So this reading on the y-axis, it tells us how much far is the object from the x-axis. You see that this reading 3 is the distance from the x-axis. So you see it is 1, so it is 1 unit away, this is 2 units away, this is 3 units away. So this point is 3 units away from the x-axis. So you can say that x gives us distance from y-axis and y reading gives us distance from x axis. Okay, so this is the thing. So this is the way to put on we can get the exact location or exact information about the point in a graph. Okay, by looking at it to x axis and looking at it to y axis. Okay, so we will use this method, this thing in order to understand how can we represent motion in a graphical way. So you can say that here I have made up a graph, yes, in which this is the y-axis, this is y-axis, and this is x-axis. So this x-axis is representing time and the y-axis is representing the distance traveled. Okay, so if an object has this is the motion, this is not the direction of motion. Okay, this is just an information. What does the information say? That an object started from O means 0 0 origin, and after 1 hour it reached a point A. So from 0 to 1 hour it has moved from 0 to A, and what is that point A? A is 30 kilometers away. You can see that A is 30 kilometers away from the starting point. Okay, so the distance traveled at A is 30 and the time taken at A is what? 1 hour. So you need to understand, if you want to get that information about the point, what you need to do, you need to draw a perpendicular on the x-axis and a perpendicular on the y-axis from that point. When you do so, you get an information. So this on y-axis, you know that information is about distance. You see, you can get distance. So this distance is 30 km at point A, and at A, what is the time taken? Time taken is 1 hour. Okay, so that is how we can get the information. Now when we talk about point B, we can draw a perpendicular here and a perpendicular here. So you can see that time taken for an object to be at B is 2 hours, and 2 hours means from A to B, it is 1 hour, and then what we have here, and when we are getting the reading of y-axis, we have it is 30 kilometers. That means the time has increased, but the distance of that object was same. It's 30. This was the distance before also and now also after 1 hour. So that means the time has changed, but the position has not changed. That means the body is at rest at position AB. And again from B to C. If we need to exactly understand how to calculate, we need to remember one more thing. That is, in physics, this is the very important thing. Final minus initial. Final means after the process or after the movement or after the thing, whatever result we have, that result is your final. And initial means before the movement or before the process, what was the condition, that is called your initial. So always remember this thing. Final minus initial, it gives you change. What does it give? Change. What does it give you? Change. Means change in position, change in time, whatever change you want to know, that change can be brought up by final minus initial. This is a very important thing. Okay, very important thing. So now let us try to solve this question. Okay. So what is the first one? The speed between OA. So you should understand the speed OA is equal to final. You see, final minus initial. What is the final position? A, and what is the initial position? O. So it is dA minus dO. It is always final minus initial, final position minus initial position. So dA minus dO. In the same way, we have time. Time also is how much? Time at A minus time at O. Why time at A? So see, time is also changing, no? So after the process, what is the time? TA, time at A, and before the process it is time at O. So what reading does this give? So dA is how much? dA is 30 minus dO is how much? 0. So what is it? TA. TA is how much? 1, and here it is 0 here. So this is kilometer and this is hour. So what do we get? 30 kilometer per hour. 30 kilometer per hour. This is the speed between OA. You will understand better as we proceed further. Okay. So the second question is speed between AB. Speed between AB. So let us talk about speed AB. So this is 1 number and this is 2 number. Speed AB. You see this motion. B is the final position and A is the initial position. So you always need to do what? B final. Means final minus initial. So what is the final position? AB. So DB minus DA by again TB minus TA. So what is the reading of DB? DB is again 30 and DA is also 30. You can see here. And A also the distance is how much? 30 and B also the distance is 30. So it is 30 minus 30 kilometer by what is the time at B? Time at B is 2 minus 1 hour. So it will be how much? 0 by 1 kilometer per hour. So the speed is 0 kilometer per hour. So speed is 0 kilometer per hour. 0 kilometer per hour means the body is at rest. It is not moving. So that is what I was talking about. When that object is at the same position but the time is changing, as you see me, no? The time is changing but I am standing in the same position, so that means I am at rest. But if the time changes and I am moving, keeping on moving, that means I am in motion. Time is changing, my position is also changing, that means I am at motion. So this graph, you can understand by looking at the graph also that whether an object is moving or whether an object is at rest. Okay. Now we are talking about the next question, that is the speed between BC. So speed, third number is speed between BC. So what will it be? So distance. So final minus initial. No. What is the final position? C. At the C, what is the speed? You can see that it is 50. What is it? 50. You can see that it is 50. And what is the time taken? Time taken is 4. Time taken is 4. So DC minus DB. And here also DC minus TB. So what is DC? DC is your how much? 50. Okay. Then what is your DB? DB is our 30 whole by what is the time at C? Time at C is 4. Time at C is 4 minus how much? Time at B. Time at B is 2. Time at B is 2. So how much will it be? It will be here. This is your kilometer and here it is hour. So 50 minus 30 it is 20 kilometer by 2 hours. So it will be how much? 10. So it will be 10 kilometer per hour. You understand? This is the way we can calculate the speed, distance and time using a graph. Now one more very important thing. One more thing that we discussed in the previous class was average speed. Average speed. Yes, we need to calculate the average speed of the journey. Means the journey means from O to C, the whole journey. No, that is the journey. So of the whole journey, what is the average speed? So average speed is from average speed of OC is the whole journey. Average speed of we discussed yesterday that it is total distance by total time travel. Sorry, total time taken. या फिर total time of travel. So total distance is how much? Final position is how much? DC minus DO. Then what is the total time? DC minus DO. So DC is how much? 50 and DO is how much? 0 by TC is how much? 4 and what is your it is also 0, so it is, so average speed becomes 50 by 4 kilometer per hour. It can be sent to as 12.5. So 12.5 kilometer per hour. So this is the way we can calculate speed, average speed using a graph. So I want you to practice more and more questions regarding these type of problems. If there are some problems in your book, please go through it and solve it. Okay. So we will try to solve some more problems in the next video. Please study well and be safe. Okay. See you in the next video.